Hello and welcome. Today we're doing a demonstration of a math problem for CST4 math. I'm going to start by reading out the question and then showing how to solve it. Here we have the question with the information. It starts with a rabbit and a frog are racing. This table shows the distance traveled by each one since the beginning of the race. And we have some values here, and we have time and distance for a rabbit and for a frog. So I've identified the information here in terms of the x and y variables, and I'll explain that next. And the question is, if the race lasts half an hour, who will win? So let's reframe the question here. If the race lasts half an hour, we're talking about 30 minutes. So what the question is saying is when x is 30 here, because this x is minutes, we want to know what the values for y are going to be. So that means we have to find equations that represent the speed of the rabbit and for the frog. So we have two equations to find. We're going to start off with the rabbit. Once we have an equation, we can answer any question. So a linear equation is represented by y equals mx plus b, where m is the slope, but in this case it represents the speed of the rabbit, and b is the y-intercept, and in this context it represents the initial value. The way to find m is by finding the difference of the y's over the difference of the x's. So we write y2 minus y1 over x2 minus x1, where the x's and y's, of course, are the two sets of coordinates that we take from the table here. So we can take any two coordinates as long as they're from the table. We can't invent them. We have to take from the information that we're given, but any two will work. So I'll start with 3 and 180 plus 6 and 360. Okay, and we're just going to write down rabbit here. Okay, so everything's clear. So now here we go. So we write down the values here for the y's and for the x's at the bottom, and we get here 180 over 3, which is equal to 60. So here we've already found out that our slope, our m, is 60. The next thing to find is our initial value here, so our b. We start again with this very same equation, y equals mx plus b, and we want to find b, and we'll be able to solve for it if we put in values for the y, m, and x. So m we already have. It's 60. And we can take, again, any values for x and y, provided they're the values that we were given. So I'll take another set of values here from the table. And here is 9, and this is 540. And I just substitute these in here, and we get the following. Okay, so to isolate the b, we subtract 540 from both sides, and we get 0 here. So b equals 0, which makes a lot of sense because that's the initial value. The starting line is at 0. In this context, that makes a lot of sense. So now we have what our equation is actually y equals 60x, okay? And we have to write the value for b, but because it's 0, there's no point adding plus 0 because 0 does not change anything in an equation when we add it. So it just stays like that. That's our equation. Before we move on to the equation, finding the equation for the frog, we're going to check this one. And I strongly recommend getting into the habit of always checking your work. So what we do here is we'll use another set of values from our table of values, and we'll substitute them here, and we'll see if it works. So we take our equation that we found, and we'll use it with the values. We can use any values that they've given us. I always use different ones here just for the purposes of changing things up a little bit. So here's our x, here's our y. So we've got 720 here equals 60 times x, and our x is 12. So we put that there. All we have to do is do the calculation. We've got 720 on this side and 720 on that side. And because this is correct, this makes sense. 720 does, in fact, equal 720. So because this is true, it also means that this is correct. Now we can move on. So we're going to do the exact same process to find the equation that represents the speed of the frog. We're going to start off with y equals mx plus b, starting with finding the m. And another notation for the difference of the y's over the difference of the x's is delta y over delta x. So sometimes you'll see that it means the same thing. We're doing the exact same thing as what we did here. We're just writing it different using a different notation. But we need to first write out the sets of coordinates we're going to use. Again, we go back to our table and we pick any two sets of coordinates that we're going to use for our equation. So we substitute them in here. And let's calculate this. We get 54 over 3, which is equal to 18. So now we know that the slope here, which is the rate, the speed of the frog, is 18. Okay. Next thing we have to find is the b, which is the initial value or the starting point. So what we're going to do is we're going to write y equals mx plus b. We know that our m equals 18. Our x, again, we take any two values that we were given. I'll take the 9 and the 162 from our table of values, substitute them in here, and we get 162 equals m is 18 times 9 plus b. So all I did here was substitute these values in here. I need to solve for b, and I get 162 on this side. I get 162 on that side plus b. And again, if I subtract the 162 from both sides, I get 0 here and just the b here, which makes a lot of sense because, again, I need my initial value to be 0. Otherwise, it would mean that the rabbit and the frog didn't start at the same place. They both started at a starting line, which is 0, and that's what that represents. So we get our equation is y equals 18x. Let's do the check. Y equals 18x. We'll use another set of variables. We'll use the 12 and we'll use the 288. Let's substitute them in. We get 288 here equals 18 times 12. Let's see if that works. 288, and we get 180 plus, we get 216. Okay, so that's not good. As you can see, 288 does not equal 216. So what does that mean? We didn't make a mistake. It just means that this equation doesn't work. And the reason why it doesn't work is because it's not a linear equation, which means that the frog did not run in or leap in a straight line on our graph, but he probably did something like that. So that requires a second function equation or a quadratic equation. So let's find it. It's a different approach. We need 3 points for that. So for the frog, we're going to write out the form of a quadratic or second degree equation, which is ax squared plus bx plus c. We're going to start by, here we need 3 points. So we're going to use the following 3 points. Okay, and we're going to write 3 equations in this format using each of the 3 sets of variables. So for the first one, using 3 and 18, we get 18 equals a times 3 squared plus b times 3 plus c, which gives us 18 equals 9a plus 3b plus c. We move on to the second one. We do the same thing. All right, so I've done the same thing for the other sets of coordinates. So we end up with these 3 equations. Now, what we're trying to do here is we're trying to find the values for a B, and C in order to have an equation here. What we're doing with this is we're going to try and use these three equations to solve for those three variables. What we'll start with is this. If you notice the plus C that's dangling off the end of each equation, we can get rid of it just like that right now for now. And so that we end up with only two variables here. Once we have only two variables, then we can use subtraction or substitution to solve them. Okay. Additionally, what I'm going to do is I'm going to, now that it looks like this and we've gotten rid of the C, we can simplify each one. So this I can factor out the 3 here and get this. Here I can factor out the 6. And here I can factor out the 9. All right. So using subtraction, I'll subtract these two. I'll start with 12 equals 6a plus b minus 6 equals 3a plus b. So this is equation 2 minus equation 1. 12 minus 6 is 6. 6a minus 3a is 3a. And the 2b minus b is 0. So I've got 3a equals 6. So divide both sides by 3. I end up with a equals 2. Great. Now I've got a. I want to find b. Let me use this one. I'll use it in the third equation over here, which is 18 equals 9a plus b. And I can rewrite this. I can flip this around, okay, because it looks a little bit awkward like this. So I can just, it's the same thing. There we go. We can write it out like that. Now I'm going to substitute here the 2 for the a here. And I get 9 times 2 plus b equals 18. So now we see the only thing left in this equation is the b, which is exactly what we want because now we can solve it. So I get 18 plus b equals 18. If I subtract 18 from both sides, I get b equals 0, which is fine. Now I've got my a and my b. I need my c. Let me go back to my one of these equations that had the c, and I'll substitute it in there. And if I write 18 equals 9a plus 3b plus c, and I substitute the a and the b, the a was 2, the b is 0, and I plug them in here. I'm almost finished now. I've got 18 equals 9 times 2 plus 3 times 0 plus c. And we see here we only have the one value here, the one unknown rather. It's not a value, it's an unknown, sorry. And everything else has a value in it. That means we can solve for this. So this is 18 equals 18 plus 0 plus c. So we can just ignore this. Plus 0 doesn't change anything. And as we can see, c equals 0. Now I have a value for a, for b, and for c. I want to write it in this form here. So I have y equals, 2, let me start that again. Y equals 2 x squared plus, well, b is equal to 0. So when if b is 0, 0 times x is 0, so that cancels it out. And my c is equal to 0, so that cancels it out. So actually, I can stop right there. And that's my equation for the speed of the frog. So let me just do a quick check on that. We're almost finished now. And we said it was y equals 2x squared. I'll use the values 15 and 900 to check this. And I'll put 900 on this side because that's my y and this is my x. So the 900 goes here. 2 times and 15 squared. And sorry, this was 450. Okay, so that's 450. All right, so 450 equals 2 times, and 15 squared is 225. So I've got 450 here and 450 here. Now it's equal. So we know that this equation is right. So now we're at the end. We've got our two equations. Let's go back and look at this sheet here, and we'll write the rabbit's equation, which is y equals 60x, and the frog speed is y equals 2x squared. All we have to do is substitute 30 in for the x on each one, solve for the y, and we'll know. So we don't know what y is, that's what we're trying to do, but we know we have our x, so we put 30 in here, and we do the same thing over here, 2 times 30 squared. And that's all we have to do. So let's see who won. So that's the distance of the rabbit. Okay, it's 1800. We don't know if those are feet or meters, but it doesn't matter. It's just the number right now. And here, remember to always do the BEDMAS, follow the order of operations. So 30 squared, we do the exponents first. That's 900 times 2, so that's 1800 over here. And look at that. They're both at the same speed. So who won? It was a tie. There you go. That's your answer. Thanks for listening. Bye.